Hi everybody. In this video, we are going to be talking about triangle congruence and uniqueness. Two triangles are the same or congruent when all of their sides and all of their angles are the same. Otherwise, they're different or unique. Now, in this video, I'm going to be making a lot of drawings of triangles. And you should understand that anytime you see a side of a triangle that is drawn in blue, that means it's free. What do I mean by free? I mean that it can be extended or shrunken. So we can make it as long or as short as we want. But if we see a side which is drawn in red, that means it is locked. What do I mean by locked? I just mean that we cannot change how long it is. So if we see a side which is drawn in red, which is this long, that means it needs to stay that long. We're not allowed to make it any bigger or smaller. And the same thing goes for angles. So if you see an angle which is drawn in red, I'm not going to be drawing any blue angles in this video. So all of the angles that you see drawn are going to be in red. That means the angle is locked, which means you cannot change the rotation between the two lines. So in other words, this line over here is drawn in blue, so I can still make it longer or shorter if I wanted to. However, I am not allowed to change the rotation like this because that would be changing the angle between them. And that angle is supposed to be locked, so I would have to keep it here. I'm not allowed to change it. On the other hand, if you see two lines intersect at this point over here, at this vertex, but you do not see this little red thing like I drew in this one, that means that this angle is not locked. So in this case, we could take this side and rotate it as much as we wanted. And since this is a blue side, not only can I rotate this, I can also make it longer if I wanted to, or shorter. And even though this side is drawn in red, I can change the rotation of it. I'm not allowed to change how long it is because it's drawn in red, but I am allowed to move it around like this as long as I'm careful and I make sure that I don't change how long it is. So if you like, you can imagine that there is a circle around that red line. And you have to make sure that as you're rotating it, you do not leave the circumference of the circle, right? So then we would be by doing that, we're making sure that the red line stays the same size the whole time, even though we are changing the angle in between the two lines. Let's go ahead and look at our first triangle. So the conditions that we are given are ASA, where A stands for angle and side, S stands for side. So ASA means angle, side, angle. And what I mean by that is we have a triangle over here, and we see that this angle is drawn in red. So we are not allowed to change how big that angle is. And we're also not allowed to change this side, and we're not allowed to change this angle. So that's where the ASA comes from. Angle, side, angle. All of these things here are drawn in red, so we are not allowed to change them. However, these two sides are drawn in blue. So we are allowed to make them longer or shorter. Now, the question that we want to ask ourselves is, can we make a different triangle? In other words, we have the freedom to make this side as long or as short as we like, and to make this side also as long or as short as we like. We're just not allowed to change anything that was drawn in red. So given that, can we figure out how to make a triangle that is different from this triangle? Well, let's see here. You can pause the video and think about it for a little bit if you like. And what I'm going to try to do is, let's see, maybe since this line is drawn in blue, what if I just make that longer, let's say up to about there, and then I will take this side over here, and I'm also allowed to make that longer or shorter because it's blue. And let me just twist this one up to here and to meet that other one. Now, is that okay, what I just did? Did I successfully make a different triangle? Well, the answer is no, I did not. And the reason for that is when I moved this side, I ended up changing this angle over here. So the angle used to be pretty small, and by rotating this side around, I actually made this angle bigger. I'm not allowed to do that because this angle was drawn in red. I'm not allowed to change how big that angle is. So I'm going to have to try again. That was no good, what I just did. What if I were to, well, let's see, there's no little angle curve inside this one. So I'm allowed to change this angle. So what if I were to take this and maybe rotate this around over to here? So now I have a triangle that goes from here to here to here to here. Is this triangle okay? Again, the answer is no, because the only way for me to make that a normal looking triangle is for me to take this side and move it this way. But I'm not allowed to do that because this side was drawn in red. I'm not allowed to change how big it is. So even though it's okay for me to change this angle, in order to change that angle, I would have to change this side, and I would also end up changing this angle also, which I was not allowed to do. So that also does not work. Right. So the answer for this is no. When we are given ASA conditions, meaning we can't change this angle, we can't change this side, and we can't change this angle, then there is no way for us to make a different triangle than the one that we're given. All right, let's move on to the next set of conditions, which are going to be SAS. SAS stands for side, angle, side. So I am not allowed to change this side. I am not allowed to change this angle. And I am not allowed to change this side. However, this angle and this angle are allowed to change. And I'm also allowed to change how long or how short this side is. So that can also change. And again, the question we're going to ask ourselves is, can we make a different triangle? So go ahead and pause the video and try to see if you can do that. All right. Let's see. So we're given a lot of freedom with this side over here, right? Because we're allowed to change this angle. So I can rotate this, and we're also allowed to change the length of the side, so we can make it shorter or longer. So really, we can take this side here and basically just do anything we want. Just spin it around and around. Woo, woo, woo. Okay, it's kind of fun, actually. But we have to end up somewhere. So let's say, what if I wanted to bring it right over here? Would that be okay? Let's say my next move would be to take this side and stretch it out to this side in order to meet that one. Well, no, I cannot stretch this side out because this side is drawn in red. So that's not going to work. What if I take this side over here and let's see, what if I bring it over here? Well, then I would have to take this side and again stretch it out like this, but I'm not allowed to do that. And I'm not allowed to do that for two reasons. Number one, this side is red, so I'm not allowed to make it longer. And number two, this angle is red, so I'm not allowed to rotate this side over here because that would be changing this angle. So that's not going to work. Is there anything that I could do? Is there any place that I can put this side in order to complete this triangle in a different way? The answer is no. Even though I do have a lot of freedom here with this side, all of the other conditions are so strict that really this is going to be the only place that I can put that side. So the answer for this one is also going to be no. We cannot make a different triangle when we are given SAS conditions. So let's go ahead and try the next set of conditions, which are AAS. AAS stands for angle, angle, side. So this angle is locked, this angle is locked, and this side is locked. Now be careful. AAS is not the same thing as this one, ASA. For ASA, this locked side is between these two locked angles. On the other hand, with AAS, this locked side is not between these two locked angles. So these conditions are not the same as the other ASA conditions. But the question that we're going to ask ourselves is the same. Can we make a different triangle given these conditions? Well, let's see here. What are we allowed to do? This side is drawn in blue, and this side is also drawn in blue. So we are allowed to change how long or how short those sides are. So what if I were to take this side over here and let's try making it longer. Let's bring it to about there. And I'm going to bring this side over to it. Okay. So did I do anything illegal so far? No. I changed the length of this side, but that's okay. I'm allowed to do that. And when I moved this line from here to here, that did not change this angle, so that's okay. I was allowed to do that also. But now this side and this side are not meeting, so let's see if we can fix that. I'm going to take this side and stretch it out a little bit. Again, I'm allowed to do that because this side is drawn in blue. So I'm allowed to change how long the side is as long as I do not change this angle over here. But in order for these two sides to meet, I would also have to take this side and stretch it out like that. All right, and they would meet right about here. But I'm not allowed to do that because remember, this side is in red. So I am not allowed to stretch it out to meet that one. So that strategy is not going to work. I'm not going to be able to make a different triangle that way. Let's try something else. Maybe instead of making this side longer, what if we made it shorter? Now it started right about here. What if I brought it to, let's say, right about here? And let's make sure that we're not changing the angle. So now I have to move this side back to where it was. Not exactly back to where it started out over here, but I mean connected to this side again. All right, so I made this side shorter. That's okay. I did not change this angle, so that's good. I can make this side shorter to bring it back over to here. Okay, so far so good, but now there's a problem because now I have to take this end point over here and bring it back over to here where it meets this line segment. But again, I'm not allowed to do this. It would be wonderful if I could make this shorter, but I'm not allowed to because this side is drawn in red. It's locked. So that also is not going to work. So really, the only triangle that I am allowed to make is the original triangle that I started with, which looked like this. Okay, I cannot make any other triangles that satisfy these angle side conditions. So the answer for this one is again going to be no, we cannot make a different triangle given AAS conditions. Let's try the next one. The next conditions we're going to look at, the next condition is going to be AAA. AAA stands for angle, 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 and that means that in this triangle, we are not allowed to change any of the angles, but we are allowed to change how long or short any of the sides are. And once again, we're going to ask ourselves, can we make a different triangle given these conditions? So go ahead, pause the video, and think about it for a little bit. Did you think about it? I hope so. The answer is yes. Now, a lot of you are probably saying, wait a minute, I thought the answer was going to be no. No, actually, the answer is yes. We can make different triangles just by changing the sides, but keeping all of the angles the same. And here I drew some of them already. You can see that in these triangles over here, all of the angles are exactly the same as they were in the original triangle. But we were able to change the side lengths. So these triangles here are different from this triangle. They're different because not all the sides are the same. Okay, remember, in order for triangles to be the same, then all of their sides and all of their angles must be the same. Otherwise, they're different. So these triangles are all different from this one and all different from each other also. And you might be thinking to yourself, well, wait a minute, Mr. Friedman. It looks like you changed these angles because this angle looks like it's bigger than this angle. But actually, I did not change the angles. Remember, an angle means the rotation between the two lines. So the rotation between this line and this line is actually exactly the same as the rotation between this line and this line. In other words, this angle here, I'm just going to approximate it. To me, it looks like it's about 50 degrees. This angle would also be 50 degrees. Okay? And this angle over here looks like, to me, like it's about 30 degrees. This angle is also 30 degrees. And this angle over here looks like it's a little bit bigger than a right angle. Let's say about 100 degrees. This angle over here is also 100 degrees. And the same goes for all of these other triangles as well. Okay, so they would all be, for this angle, about 50 degrees, here about 30, and here about 100 degrees. So we didn't change the angles, we only changed the sides, but that's okay. We were allowed to do that because remember, the conditions that we were given were just A. So yes, we can make different triangles given angle conditions. Let's move on to the next set of conditions. SSS, side, side, side. Can I make a different triangle with these side, side, side conditions? So all of these sides have to stay exactly the same size, but we are allowed to change any angles that we want. So can we make a different triangle? Go ahead and pause the video, see if you can do it. All right, so what I'm going to try is, let's take this side here, and even though we're not allowed to stretch it out, make it longer or shorter, since this angle is not locked, we can take this side and maybe just rotate it around like this. And I'm doing my best as I'm rotating it not to change how long it is. So let's rotate it to about there. And we're also allowed to change this angle. So let's see. I can take this side and rotate it. Again, I'm doing my best not to change how long that side is. I'll rotate it to meet that one over here. Now, oh, look at that. I made a triangle. So is that it? Was I successful? Was I able to make a different triangle? Well, unfortunately, the answer is no. And here's why. This triangle that I just made is actually just the old triangle upside down. In other words, let me go ahead and construct the old triangle again. I'll use a little Microsoft Word magic here. Okay, the original triangle that I had looked like this. Okay? Just like that. And these two triangles are actually congruent. They are the same. They are not unique. They are not different. Let's go ahead and remind ourselves what we mean by congruent and unique and same and different. Remember, two triangles are the same or congruent when all of their sides and all of their angles are the same. Otherwise, they're different or unique. So going back to this example over here, are the sides and the angles the same? Well, yeah, they are. The bottom of this original triangle is the same as the top of this triangle. This side is the same as this side, and this side is the same as this side. So all the sides are the same, obviously, because we had side, side, side conditions. So we were not even allowed to change the side lengths. But all of the angles are also the same. So, in other words, this angle is the same as this angle over here. And, well, let me try this. This angle is also the same as this angle. And this angle is also the same as this angle. So all the sides and all of the angles of both triangles are still the same. So even though it's upside down, it's still considered to be the same triangle. In other words, it's congruent to the first triangle. And the answer here is another no. We cannot make a different triangle. All right. We're going to move on now to the last set of conditions, which are SSA conditions. And SSA stands for side-side angle. Now for this one, we're actually going to look at two different starting triangles. So this triangle here, which I call triangle 1, and this triangle here, which I call triangle 2, these triangles are different to begin with. But for each one of them, we're going to be asking ourselves, can we make a different triangle? And it's also important to understand that SSA is not the same as one of the other conditions that we looked at, which was SAS. For SAS, the locked angle was in between the two locked sides. If you look at the picture here, this angle, which is locked, is between this locked side and this other locked side. So the locked angle is between the two locked sides, whereas in the triangles that we're looking at now with the SSA conditions, the locked angle is not between the two locked sides. In this triangle or in this one, the locked angle is not in between the two locked sides. So it's not the same as the SAS conditions that we looked at earlier. Now I'm going to start with this triangle over here. And I'm going to ask myself, can I make a different triangle even though I'm not allowed to change this side or this angle? But I am allowed to change how long this side is because that side is drawn in blue, so it's free. And I am also allowed to change these two angles over here. So go ahead, pause the video, and see if you can do it. So actually, even though I'm not allowed to change how long this side is, this angle is not locked. So I can rotate this, and I'm going to rotate it to here. And I did my best to keep this side the same length that it was originally, because I'm not allowed to change how long it is. Now the question is, can I take this side and extend it in order to meet this side? Well, this side is drawn in blue, so yes, I am allowed to extend this side here. And even though this angle is locked, that's okay because I did not have to change this angle when I extended this side. So that's not a problem. So the answer in this case is, yes, I can make a different triangle. However, I'm not going to put yes over here just yet. And the reason for that is I'm going to look at this other starting triangle. So for this other triangle, I also have two locked sides and a locked angle. And I'm going to ask myself, can I make a different triangle with this one? Well, let's see if we can do the same trick that we did with the last triangle. So we notice that this angle over here is not locked, which means we are allowed to take this side and rotate it as long as we do not change how long it is. So let's say we rotated it to about there. Then the question becomes, can we take this side and bring it around to meet this one? Well, it is a blue line. It's free. So we are allowed to change how short it is or how long it is. However, if we try rotating it in order to meet this side over here, we run into a problem. By rotating it, we just changed this angle, but we were not allowed to do that. This angle was locked. So by taking this side to meet this side over here at this vertex, we did something which we were not allowed to do, which was to change this angle. So that's not going to work, but let's try something else. Maybe instead of rotating it clockwise, I'll rotate it counterclockwise. So it started about here. Let me rotate it to, I don't know, I'll rotate it to around there. And then I'm going to take this side and bring it over to here to meet it. Is that okay, what I just did? Well, the answer again is no, because by doing that, I changed this angle over here. The angle used to be this big. I just made it smaller. The rotation between these two lines is now less than what it was originally. So when I started with these two sides and this angle, I was able to change it in a way that was legal. And I see that I can make the original triangle, and I can also make this new triangle, no problem. However, when I tried doing the same thing with this side and this side and this angle over here, it turned out that this right over here, which is the triangle that we had originally, that was the only triangle that satisfied these conditions over here. Any other triangle that we tried to make didn't work. We ended up changing this angle. So the answer for this question with side-side angle conditions is sometimes. Sometimes we are able to make a different triangle, and sometimes we are not. It depends on the original triangle that we are given. Alrighty, so I hope that was helpful. If you have any questions, let me know. Have a great day, everybody.